All right, so zeros of a function. It is the x values. So it's the value of x when the function, which is y, equals 0. That is what a 0 is. It's the same as an x-intercept. So every time the graph goes through the x-axis, there is a 0. Okay? So I want you to look at that graph. Show me with your fingers how many times does it go through x. Count it up. 3 times, right? It crosses here, here, and here. So that means that we have 3 real zeros. So where does it cross? The first time it crosses at -2. The second time it looks like it's about +1. The third time is +4. When you write it in factor form, every place that there's a 0, you have to put a parentheses. Okay? So there's 3 zeros, so I want you to make 3 parentheses. So 1, 2, 3. And then in front of each parentheses, put an X. So in order to get -2 as an answer, that means my factor has to be x plus 2. So if you take x plus 2 and set it equal to 0, you get x equals -2. So what am I doing with the sign as I go from here to here? What happens to the sign? We flip it, right? So if I have a 0 at +1, what am I going to put here? -1. Good job. And the third one, instead of a +4, I'm going to put -4. Now, the last thing you need to look at is, what is the right arrow doing? What is the arrow doing on the right side? Is it going up or is it going down? Up. So because it's going up, I just want you to get in the habit of putting a +1 in the front. All right, let's do our next one. How many times does this one cross through? 4. So we have 4 zeros. So my first one, so this one looks like it's counting by a half, which is kind of ugly, but we'll go with it. So the first one is at -1. The second one is at -0.5. The next one is at +1. And the fourth one is at +2. How many parentheses are you going to make on that line? 4. Let's make 4. So we got 1, 2, 3, 4. And remember, when you go from here to here, we just flip the signs. So the first one is at -1, so I'm going to put a +1. The second one is at -0.5, so I'm going to put a +0.5. Ran out of space a little bit. Hold on, let me fix that because that's going to bother me. Make sure my 0 can fit. The next one is at +1. So I'm going to put a -1. The last one is at +2, so I'm going to put a -2. So what do you think this graph, does it have a positive leading coefficient or a negative leading? Positive, because both sides go up, so we're going to put our +1 in the front. So yeah, these go pretty fast. Okay, so now we're going to talk about a double root. So if it's a double root, what that means is it bounces off of the x-axis. It doesn't go through, it bounces, okay? So when you look at this fact, at this very, very tiny graph, we have x minus 4 squared. And the reason why it's squared is, if I zoom in really closely, that's 4. Notice that the graph comes down, it hits the 4, and it bounces back up. It doesn't go through. So that's what happens when it is squared. It doesn't cross it. It still touches it. Remember when we talked about the quadratic formula and the the discriminant? If the discriminant is 0, we only get 1. This is what that graph would look like. Thank you so much. This is what the graph would look like when the discriminant is 1. It bounces. All right, so let's practice making a sketch. So we have 2 real zeros. So that means I'm going to make 2 parentheses. It also says that it's a positive leading coefficient. So I'm going to put a +1 in the front. And the zeros are at, oh, sorry, it has 3 real zeros. It has 2 real zeros here and here. Sorry, so here, here. And then this one, it bounces. So there's 3, so we need to make 1 more. Now, when it says it bounces, what this tells me, bounces is a double 0. That means it's going to bounce at 1. So that one factor is going to be squared. So I'm going to take this, put an x in front of each one. Okay. So for my first one, which is -4, I'm going to put a +4. For my second one, which is a +3, I'm putting a -3. For my third one, which says it's at +1, which is the double, I'm going to put a -1. Okay. And notice it said it has a positive lead. So altogether, when you count up the exponents, because every factor has an invisible power, so this one has an invisible power of 1, and this one has an invisible power of 1, what do you get when you add up these numbers? What's 1 + 1 + 2? 1 + 1 + 2. 1 + 1 + 2. 4. 4 is what kind of number? Positive. Is it even or odd? So this is a 4th degree, which is even, and it told us is a positive lead, which means that both arrows, when we sketch it, they both have to go up. So let's go ahead and sketch it. So I want you to go to your x-axis, and the first thing we're going to do is put down our point. So put a point down at -4. Put a point down at +3. And then I'm going to put the one that occurs at +1. I'm going to make that one red. Because remember, when I make my sketch, it can't go through the red dot. It has to bounce off the red dot. So I know that my function, when I sketch it, it's going to come down. It goes through the purple, makes a U-turn, hits that red dot. It doesn't go through, bounces back down, makes a U-turn, comes through the last one. That would be a sketch. Kind of messy, but you get the idea. So again, let me do that one more time. We know that it's a 4th degree, and we know that both arrows have to point up at the end. So whatever I sketch needs to have 2 up arrows. Okay, so I'm going to start from the top. It's going to come through the purple. At some point, it's going to make a U-turn. It's going to come back up, bounce off the red. Thank you. Bounce off the red. It doesn't go through. Makes a U-turn and then comes through at that last point. We're not concerned with how far we go down to make our U-turn because it's a sketch. It's not accurate. It's not going to be exactly right. Okay, let's go to still on page 7. Let's go ahead and answer some questions about this. We're going to bring it all together. So first of all, man, there's a lot going on here. Let's start off with our end behavior. So this is the left side. This is the right. So on the left side, the arrow goes down. So I'm going to put a negative infinity. On the right side, the arrow goes up. So I'm going to put a positive infinity. Okay, so that's our end behavior. Now it's odd. And remember we said for an odd degree, it doesn't have an absolute max or min because the arrows keep going up and keep going down. But a relative min, that's kind of like saying, where is there a dip? And I do see a dip. I see a dip about here. So I'm going to try my best to approximate where that green dot is. And this is a really funky graph because the x-axis is counting by 1s and the y-axis is counting by 2s. So my guess would be this is about positive 1/2 and this is like about -1. So I'm going to call that positive 1/2, -1. And remember, the max, that's kind of like the heel top. And I do have a heel top right here. Okay, that one's at a nice easy point. We can name that one easily. So what are we going to call that purple dot? Where is that purple dot? So x is what? What's the x value for that purple dot? -2, and the y value would be +6. Good. All right. So what we're doing is we're bringing everything together that we talked about Monday, Tuesday, and Wednesday. It's all coming together. All right. How many zeros does this graph have? How many times does it cross the x-axis? Show me with your fingers. I agree. There's 3. Good. So there's 3 real zeros, and they occur at x equals. So we have this one, which is -3, and then this is 0 and 1. Now, when it asks you to write it as an x-intercept, that just means we write them as an order pair. Same numbers, but we write it as an order pair. That's the difference between the two. It's the same 3 places, but this one I wrote as an order pair. All right, what about the y-intercept? Where does this cross the y-axis? It looks like it crosses the y-axis at 0, 0 also. Whenever it crosses at the origin, that's the x and the y-intercept. Okay, every single odd degree, if it's odd, your domain and range will be all real numbers. So odd degree functions are very easy to do. Every odd degree has that domain. All right, last thing we're going to do, because there are 3 zeros, I'm going to make 3 parentheses. Put an X in front of each one. For the first one, it crosses at -3, so I'm going to put a +3. The next one crosses at 0. 0 doesn't have a sign, so I'm going to leave this one empty. He could just be by himself. You can put a +0 or a -0. I would not mark it wrong. But would you agree that adding 0 and subtracting 0 doesn't change the number? So that's why you don't have to put it. And then for the last one, we're going to put our -1. Moving right along. All right, let's look at our next graph. All right, what's happening on our arrows? Both are going up, so that means my end behavior for both will be positive infinity. So for a max, I'm going to call it absolute max. We don't have any. For my absolute min, to me, these look like they're at the same point. So I'm going to just guesstimate these and say that it's -4. I'm going to call that -40 because it looks like the y-axis is counting by 40s. So -4, -40, and +4, -40. Because I can't tell which one is higher. I mean lower. So they're going to both be absolute. They're also going to be called, they're absolute, and you can write local. So can you change that? Sorry, y'all. Hopefully y'all can erase. If not, just write really small. But that's going to be your local and absolute min. And the reason why I'm calling it both is because I can't tell which one is lower. So that one is going to count as both. All right. Then we do have a hilltop. The hilltop is at, it looks like that's like 0. I'm going to just call it 200, even though it's a little bit higher. We're going to call that the local max. That would be at 0, 200. And that's this point right here. This is your local max. This is your absolute and local min. Okay. How many zeros do we have? How many times does it cross? Show me with your fingers. How many times does it cross X? 4 times, yeah. So they're at X equals. So I'm going to call this one -5, -3, +3, and +5. So it's at -5, -3, +3, and +5. Let's go ahead and write that as our x-intercepts. They did not give us a lot of space. And your y-intercept looks like it's about 0, 200. All right, is this one even or odd? Who says it's even? Who says it's odd? So that means my domain is all real numbers, but my range is not. So my range goes from here up. So that looks like that's about -40 to infinity. And lastly, let's go ahead and write our factor form. Put an X in front of each one. Oh, there's 4, sorry. And flip the sign. So +5, +3, -5, -3. And this has a positive lead. Oh, I'm sorry. right, one last question. So do we think this has an even or an odd degree, this graph? Who says even? Who says odd? Yep. Do we think it's positive or a negative lead? Remember, you look at the right. Who says it's positive? Who says negative? I agree. The function has how many zeros? How many times does it cross the axis or touch it? 2. One of them is a double, but we'll talk about that in a minute. And those 2 are at x equals -2 and also x equals +3. The 0 at 3 is a double root. So I'm going to make 2 parentheses because I only have 2 zeros. Flip the sign. This becomes a +2. This becomes a -3. But because this one is a double root, this factor, you need to put an exponent on it. That's what double means. So the last thing we're going to do, Otanel, is put our leading coefficient. And do we think it's, we said it was negative, so we're going to put a -1 in the front. So that's the end of the lesson. So now we're going to do our bell work at the end, and then we'll be finished. So take out your bell work packet. And then take a couple minutes. I want you to try to answer this one on your own. Use a pencil, because if it's wrong, you can always erase it. We do have a skills check on Friday. Skills check Friday. You can use your notes and your bell work. So one of these is going to be double. So just take a guess. Try your best to answer the questions about this graph. So show me with your fingers, how many zeros do we have? How many times does it cross or bounce? We have 3. And those 3 occur here, here, and here. So it would be x equals -3, -2, and +1. So let's go ahead and make our equation. So y equals, make 3 parentheses. Put an x in front of each one. And then we're going to flip the sign. So you see how that's a -3? That's going to become a +3. And this one here, that's a -2. So that becomes a +2. And my last one is a +1. So that becomes a -1. But I'm not done. Because right now, if I add up the invisible exponents, that's a 3rd degree function. But we know it's not an odd degree. It has to be even. So one of those needs to change to a 2. One of those exponents changes to 2. Which one is the double? The x minus 1. Good job. So I'm going to change that to a square. And now when I add it, it is a 4th degree, and you could put your plus 1 in the front.